Good morning or good afternoon, depends on where you are. Today I want to talk about the artificial intelligence in general. So we'll discover many topics about the artificial intelligence. My name is Ndikumana Sam. I have a PhD in computer engineering. This is what we cover in this lecture. So when we talk about the artificial intelligence, it is very hot topic because of the advancement of the computing and also the advancement of the technology and also the processing capability of the computer. So the artificial intelligence, it was defined as like enabling technology that enable the computer and the machine to simulate the human learning comprehension, and also how the human solve the problem, decision making, and also to get the creativity and the autonomy. So in other words, the AI, it is a technology that enables the computer to learn like human, to solve the problem, to make a decision, and also to have some more creativity. So where we can have like the image, or we can have the language interpretation. So there are many things that can be done by using the AI. So we can define the AI as a set of the technology that enable computer to perform a variety of the different function. So, for example, for understanding and translating the spoken language, so you can translate from the English to French, or you can translate from French to the English by using the AI. So I read the another definition we can give for the AI. It is about the field of in computer science that study about the method and the software that enable machine to perceive the environment and use the learning and intelligence to take the action. So in order to maximize the chance to achieving define the goal. When we talk about the AI, when we talk about the AI, it is global. So machine learning is the some field of the AI. So you have the artificial intelligence. Then inside of the artificial intelligence, you have the machine learning. So another word, machine learning is the subset of the AI. So which try to use the neural network to solve the complex problem without explicitly programmed. So another word, machine learning allows the computer to automatically adjust and enhance themselves and to acquire some more experiences. So when we talk about the AI, it's a big field. Instead of the AI, we have subset of we have the machine learning, which is subset of the AI. Inside the machine learning, we have what we call the brain inspired. Then inside of the brain inspired, we have a SNN, and you have NN, and you have the deep neural network. So let's start by a neural network. So when we talk about the neural network, the neural network try to mimic the complex function for the human brain. So where you have the different nodes which are interconnected, so that they can process the information. So in other words, you have the input, you have the hidden inside, then you have the output. So those neurons are connected so that they can process the data so that they can produce the output. So in other words, the neural network, they try to mimic the complex function of the human brain. When we talk about the neural network, the importance for the neural network, it is about the node. So we have different nodes which are connected. So we have different nodes, and those nodes they receive the input. So this is an example. We have different inputs. We have x1, x2 to the xm as input, as input. Then we have the weight. Each input they have assigned to the weight. So the weight, how the input is very important comparing to the others. So then we have the input which are joined to the weight. Then are fitted into to the model. So where we have the linear combination, and then we have the bias. We have the bias. So then from we have the input, we have the weight, we have the bias, then we have after combining them, this is we can call the linear combination. Then we have the activation function. Then from that we can produce the output. So the output, it depends on machine learning type. For example, if you have the classification problem, so you can give, for example, the image to the neural network. They try to classify the image. For example, if you want to classify the dog and the cat, so that they can differentiate the dog with the cat. So this is some kind of the classification problem. So where at the end you have the activation function, then you have the output where you can know that this is dog and this is the cat, and to differentiate them. So the key important neural network, we have what we call the feed-forward neural network, which consisted about the input. You have the input, then you have the different weight, then you are feeding to your model. You try to predict the output. So this is the output you predict. Then you can try to minimize the error between the actual both the data and then the predicted data. So there is the difference between the predicted output and the actual output. So in other words, the input layer, they receive the data, then each input assigned to the weight, that this is the weight, that indicating the importance of the predicted output. Then input, if the high weight have the high influence in the prediction. Normally, initially those weights are assigned randomly. Then after prediction, so we have to minimize the error function between the predicted output and also the actual input. So how to minimize the error? So we can use the cost function. So we have the cost function, so which measure the accuracy of the model by identifying the predicted and actual value. For example, if you are predicting the price of the house, so you already have the historical data about the cost of the house in different areas. Then you use your model, you try to predict the price on that area. Then you compare the exact actual value and the predicted value. So the difference is what you call the error. So for that, you have to measure the accuracy of your prediction. Then you can use the cost function. So the objective of the cost function is to minimize the error. So normally, sometimes we can call it the cost function as the loss function. So we try to play with the weight, because initially the weight is assigned randomly, but you can adjust the weight so that this cost can be, or that error function can be minimized. So when you talk about the minimization, it's like this cost function, they can reach to the minimum point. So now we have talked about the feed-forward neural network. Now we can talk about the back propagation neural network. So the back propagations, it helps to adjust the weight so that we can minimize the cost function, or we can reduce the error in our prediction. So if I come back to this figure, you have different inputs. Then those inputs are fed into the hidden layer with the different weight. Then we try to predict the output. So then we try to see the difference between the predicted output and the actual output by using what we call the cost function or error function. So to minimize the error function, then we can propagate the error back. We send the error back to the neural network in a backward direction. Then we try to play with this weight, those weights, so that by adjusting those weights, we can minimize the error function. So this is what we call the back propagation in the neural network. So how we minimize the weight? So I'm going to discuss about the gradient descent. So initially we assign the weight randomly, then you predict, then you get the error function, then you do the back propagation, where you feed the error back to the layers, so that they can adjust the weight, so that the error can be minimized. So finding the weight that minimizes the error, it is corresponding to the finding the lower points. So if you have this function, if you have this function as the error function or the cost function, you try to minimize it until you reach to the minimum point. So you see we have this point. We can call those local points. But among those 4 local points, we have the minimum point. So where you want to reach. So is where we have the lower error function. So the gradient descent. So imagine you are on top of the mountain. You are going to go to the valley. So you have to go down until you reach to the valley. So it is like you from the top, you try to minimize the error until you reach to the minimum point. So when you talk about the gradient descent, it is about the first order optimization algorithms. So which is used to find the record minima of an objective functions. So of course, when you talk about the gradient descent, we talk about the direction of the descent. So if you go like the positive gradient descent, instead of going down, you go up. But for the negative gradient, so you go down. So the negative gradient that indicates the downward slope of minimizing our cost function. So of course, in our scenario, because we want to minimize the cost function or the error function, we cannot go on a positive gradient. We go to the negative gradient. So this is an example. We start from here, we go down. So which is corresponding to this one. So when we minimize we minimize the error function. So when you go down downward, so depends on the step. So if, for example, if you're on top of the mountain and you want to go down to the valley, if you use you have to know how many steps you are using to go down. For example, if you have you are coming from here, you want to go to this minimum point. So this is the step size. So this is the initial weight. Then this step size, you can call it the learning rate. Then after taking this step, you get the new weight. Then you take another learning rate. Then you go to the new weight until you reach to the minimum point. So this is, you can see it is the minimizing problem So the learning lets to play a very important role for minimizing the cost function. So is that why it is very important to adjust the learning rates, which determine the step size. So if I go back to this example, so we are on this, we want to go to this minimum point. So you have to play with the step size until you reach to this point. So then we talk about the activation function. So it depends on the output you are expecting for your model. Then if you have the classification problem, so you should have the specific activation function for the classification. If you want to predict the probability of the image to be representing a dog, not a cat, so you should have some probability to get that output. So the activation function, in other words, it is a function that calculates the output of the model based on individual inputs and the weight. So when we talk about the activation function, normally it is the mathematical function which uses the neural network so that you can introduce the linearity and non-linearity into the model so that you can produce the output to the next layer or output for at the end of your prediction. So this is the different kind of the prediction model for the neural network. So if you are interested in revising those activation function, I recommend you to visit this work. So they discuss in details how to use those different activation functions. So now we have already talked about the AI. Now we have talked about the machine learning. Now we have talked about the neural network. So there is another part which called the speaking neural network, which is also the brain inspired network. So it was developed in computer neurosciences to replicate the behavior of the organic neurons. So both neural network and the speaking neural network, both are the machine learning. Of course, both are the inside of the artificial intelligence, so that they get inspiration from the human brain, but they are different in the way they process the information. So the skipping neural network, it is some kind of the discrete event. So they try to use the operation on a discrete event. But for the ANN, there are no continuous signal. So this is the key difference between neural network and the skipping neural network. So now we have the deep learning. So the deep learning, it is now we go inside of this one. Already talk about the AI, you already talk about the machine learning, you already talk about the neural network, you already talk about this skipping neural network. Now we are talking about the deep learning. The deep learning, so of course, subset of the machine learning that use the multilayer neural network. So you have in multiple layers, so is that we call it now deep neural network, so that we can simulate the complex decision-making power of the human brain. When you talk about the machine learning, the data is very important. So we have some, I can say, type of the artificial intelligence. We have what we call the supervised learning. In supervised learning, you have what you call the label data. So you have the environment has a set of the input and the corresponding output. You have the input and the corresponding output. This is an example. The input is the image. You have the image and the description of this image. so that you can train the model to identify if it is a cat or a dog. But semi-supervised learning is where you have the label data and unlabeled data. For example, if you take this one and miss this one, so is what you call the semi-supervised learning. So we have the partial label data. So we have another category called unsupervised learning. So unsupervised learning, it is this way. You have unlabeled data. So you have the image, but you do not have the description of that image. So this is another kind of the type of the learning approach. So where the agent or neural network system, they try to learn the structure from the data. So now we talk about supervised learning, we talk about unsupervised learning. So now we have what we call the reinforcement learning. So in reinforcement learning, we have the agent which have to learn to take the action. So it is like some kind of the trial and error. So you have an agent, it take the action to the environment. So then based on the action it take, you get the reward. Then take an action, get the reward. Of course, every time you take an action, the environment will go to another state. So this problem can be modeled by using the Markov decision process, where you have an agent at every time in a state, it take action. By taking action, it receives the reward. So this is kind of the reward. Then it translates to another state. For example, it was in state ST, it take the action, it get the reward, it go to the state ST plus 1. So on the characteristic of this one, you have the state, you have the action, you have the transition probability, then you have the reward, then you have the discount factor. So the discount factor, it is to give the weight immediate reward and the reward you can get in the future. That we call the discount factor. So in other words, when we talk about the deep reinforcement learning, so it's a subset of the machine learning that combine reinforcement learning and the deep learning that I have already explained before. So this is some kind of the reinforcement learning, where you have the multi-stage decision-making problem by interacting the environment and learning from the experience. So where you have the reinforcement learning, so that we can have the state and the action. Every time you take the action, you get the reward. Of course, you aim to maximize the reward you are getting. So this is an example of the mouse, which trying to go inside of this breeding looking the food. So you take the action to move from room to the room. If you get the food, you get the reward. If you miss it, you can get the penalty. So this is some kind of the reinforcement learning. So if you are interested, so you can go in the details for the very basic reinforcement learning scenario described in this link. So now we're talking about the Multilayer Perceptron. Perceptron. The Multilayer Perceptron, you have more than one hidden layer. So you have a multiple hidden layer. So you have the input, you have the output, in between you have a hidden layer. So you make the input, this is the corresponding weight, you give inside to the layer, this is the different layer, then output. So you can see from the input to the output, you have different hidden layers. So this is somehow complex than the simple neural network. So you have a air layer between the input and the output. And normally the performance of the machine learning depends on the number of the data you have. So if you have a large amount of the data, so you can have a very good performance. But if you have not enough data, so the performance will be very limited. I know this period it is very hot topic about the large language model. So you train the model on a large data set so that the model they can handle the very complex task. So I think we are familiar about the ChatGPT DeepSeek. So they train those model on the large amount of the data so that those models they can handle complex tasks like they can reply like a human or they can generate the image, so they can do different things because of they have been trained by using the large amount of data. So we have, I'm going to talk another machine learning approach which is very interesting. So it's about the transfer learning. The transfer learning, this is, it works like the student-teacher relationship. So it is like you have the model, you train the model by using the large data set. Then you transfer the model to another area where you do not have a large data set. It is like the teacher as an expert, which transfer information to the student, which is the learner. So the same things happen for the neural network. So while we train the model on a big amount of the data during the training, then you can learn about the weight and the bias. Then those weight and the bias can be transferred. It can be transferred to another device for testing or for training the same model by using a very limited data set. So this is very interesting. And also the network can use the pre-trained weight instead of starting from the scratch. So we have another kind of the machine learning. So what you call it, the continual learning. Continual learning. Normally we make a model by using the data, we train the model. Then after training the model, we deploy the model, then we use it. This is the end. But continual learning is very interesting. You have adaptive. So you train the model by using the model, then you deploy the model, then you keep improving the model by feeding the model with the new data. So this is an example. You train the model, for example, for handling the task A. Okay. Then if the task B, you can give another data so they can handle about the task B so that they can handle task A and the task B. You give another data so that it can also learn the task C so that they can handle the task C. Initially it was handling B, but it keep improving so that it can handle B, it can handle C. So now we have some, we call it the stability and also the elasticity. So which depends on the model that you keep replaying with the data so that they can have the representation, you can have regularization, then you can have the optimization so that you can have the model which can handle different tasks. So those tasks, they can be in computer vision, natural language processing, reinforcement learning. So the model, it keep improving. So it adopts and evolves autonomously. So we have here, we have what you call the recurrent neural network. So this is another machine learning approach. So normally, if as human, when we think something, we do not start from the scratch. There's something we already know before. It is like incremental. We increment our knowledge. So it is like we have this information, we get the new information, we get the new information, we get the new information, which can help to improve. So it is like the human think continuously. So it doesn't start it doesn't restart every moment. So our thought is somehow persistent and not discarded and recreated repeatedly. So this is an example. You have the input, you get another input, you get another input, you get another input. So you have the input x0, you fit into the model, you predict the prediction, and this prediction you fit into the model with the new output, you predict again. The output you fit to the new model with the new input, you predict again. Then you fit the output with the new data and you predict again. So this is we call it the recurrent neural network. So which is very popular, especially when you have the time series data. You can predict, for example, if you are predicting about the weather. So you have the historical data about the weather condition, maybe for month or for years. Then you can do the information. Then you predict like the next week or next month or next year how the weather will be look like. So this is some kind of the example for the recurrent neural network. So I can give you an example of recurrent neural network where they talk about the LSTM. LSTM in Floyd is like, we call it a long short-term memory network. So in the LSTM, long short-term memory, so what is very important? So you have the input, which is the sequence of the data. Then you fit the model, you try to predict, and then the output is fed to another neural network layer. Then with the new output, then you try to predict. So this is this is one kind of the recurrent neural network, long short-term memory, which is very popular. So this is a representation of the network layer. Those are the network layer. Then this one, they are representing the pairwise operations. And we have different activation functions. Then we have that concatenate. And then you have the vector. So this will have different vector transfer. Then you have the some copies. So this is what is important for the LSTM. It is about the cell state. The cell state is very important because the cell state is how the information is followed from one layer to another layer. So this is, you have the cell state T-1, which is followed into T. So in between you have different gates. I will discuss about the gates. So in the LSTM, can add or remove information for the cell state, which is controlled by the gate. So we have different gate. We have a forget gate and we have the input gate. So now when we talk about the gate, so the gate regulates the flow of the information, how the information are added to the cell and which information to put. So, which is consists about the sigmoid neural network layer and the pointwise multiplication operation. So the sigmoid layer outputs sometimes between 0 and 1, so which determine which information is allowed to pass or which information is allowed to forget. For example, if the value is 0, it means that block everything, forget everything. But if the value is 1, it means allow everything to go through. So this is ready to go about the forget get. The first step is the neural network. It is to determine the information you have to put on this set state, and which information to put and which information to discard. So is that we have this this humanoid function at the forget get. So that you have this is the forget get. You have the weight. You have the input from the previous layer. And then you have the input for the current layer. So you have the input from the previous layer. You have the input from the current layer. This is the output of the previous layer. This is the input for this current layer. Then you go inside of this sigmoid layer. Then to decide which information to put to this cell. So the value is between 0 and 1. If it is 0, forget everything. If it is 1, let the things pass. So after that, we have another, we call it the next step is about to decide the information to put. So where we have what we call it the input layer. So this is the input get layer. So which decide which information to add to the cell state. So here we have the turn function, which created the candidate's value that could be added to the layer. So this is the input layer, so which you have this sigmoid, which depends on output for the previous layer, input of the current layer. Then you have the bias, then you fit to this one. Then after that, you have another one, which is turn functions, so which is put inside. Then you can set the information to update for this layer. So once the next step is about the combination. So the order cell CT1 is updated to the cell CT. So we come from this one, we need to update to this one. So the model needed to decide what is going output based on a cell. So the sigmoid function decide what part to pass the cell output. The turn push the value between -1 and 1, and they multiply it by the output. So this is the cell state output. So this depends on forget get the cell state from the previous layer, the input get layer. So this is from this turn function. Then you produce the output. So this is the output. So this output can go out. Then you fit this output to the next layer. So this is the LSTM long short memory, which is very popular. So it is very popular. Now we have a convolutional network. Convolutional network also it has lots of applications. The CNN have different advantages and several advantages because it is somehow they represent how our visual system processes the information. So by using the 2D and 3D image data, so that we can extract the future from the image. So normally it consists about two components. It's about the future extraction and also the classifier. For example, you have the image, you feed the image, then you have you have a conversion layer, you have a max pooling layer, you have conversion layer, you have maximum pooling layer. Then this is when we call it the future extraction. Then you have the classifier. If I give an example, so you have the image from the human, you want to predict if from those images, if it is man or a woman. So this is classification of two categories. Either is a man or a woman. So this is the problem now become classification. So we are at the end. based on the image, you have to clarify if it is a man or it is a woman. So this is, you have the image, then you have the conversion layer, then you have the pooling, so which is playing about the size. Then you have at the end, you have the full connected layer, so that you can predict. So if you're interested, I recommend you for this link from the Stanford University. So you can check this link from the Stanford University, and also you can read this manuscript given to the below. So we have another, we call it the Generative Adversarial Network. And sometimes we define the GAN. So the GAN is somehow the unsupervised deep learning, which involved two neural network. You have the generator and you have the discriminator. So the generator and the discriminator, they try to compete in a zero-sum game. So imagine you have the actual sample of the data. So the generator, they try to generate the data which is similar to this sample. So the generator try to generate the sample. See the generator, they try to imitate this sample to generate the sample. Then the actual sample and the generated sample are fed into the discriminator. Then the discriminator, they try to distinguish the real sample and the generated sample. So of course, by minimizing the error function. So when we talk about the error function, it is the difference between the real data and the generated data. So when the error function is minimized, is very low, so that the generated data is very close to the actual data. So this is, we call it the generative adversarial network. It is like, for example, you have my images, and then generator, they try to generate the images similar to my real images. Then the discriminator, they try to check my real image and generate the image. They try to minimize the error until that the generated the image is very close to my image. So they have lots of application. So if you're interested in GAN, so I recommend this survey so that you can see how the generated adversarial network works. Also, now we have another machine learning approach. We call it the federated learning. Federated learning, normally for the traditional machine learning, we collect the data, then we send the data to the central server. Then the central server, they train the machine learning model by using those combined data, so that they can make the prediction. So federated learning is totally different than that one. So in federated learning, so the data are distributed at the different devices. So what the devices they try to do, they try to download the model. The device, they try to download the model. Then they predict. Then they share the learning parameter. So the training is distributed across the edge device. It can be the smartphone, they can be the laptops. Then the model parameter are shared. So then we share the model parameter. So you do not share the data, you share the model parameter and you keep the data in your local device. So only what is shared is about the parameter. Share it to the central server for having the global overview. So it have many advantages. The first advantage is about the privacy. So the raw data stay on an individual device. Okay. And other things, it reduces the bandwidth. So we do not need to send the data, all the data to the server. So you're only sending the learning parameter to the server. So normally the learning parameter, it is not a big size. So another thing is very important is about the privacy. So the data, you don't share the data remaining on a device. You only share the learning parameter. So now we have another hot topic in those days. So we call it the transformer. So the transformer is some kind of the improvement of the recurrent neural network. We have already talked about the long short-term memory. We have talked about the GAN. So the research continue to advance. So now we have what we call the transformer, which is based on encoder decoder. So it is widely used in a modeling of dependencies. So this is a given example. You have a transformer for translating English to the German. So you feed the information, the encoder, then the decoder produce the German language. So the key success for the transformer is about the self-attention mechanism. So, which is allow the transformer to be more successful than the existing machine learning. So this is the transformer. I like this paper. It is coming from this paper. It is the attention is all you need. So this is the structure they propose for the transformer. So where you have the input, then you have the input embedding, then you have the position encoding. So for example, if you have let's take an example for the language. So you have the input at the language. For example, I speak English. So then you go to the embedding, so that you have encoding, so that you can transform those language to the numerical value. Then you have the position encoding, so that where the position the data come from that one or the word come from another one. So then you have the position encoding, then you fit into the multi-head attentions, and then you have the different normalization layer. Then you feed it to the decoder, then you produce the output. So the encoder map input a sequence of symbols to the sequence of continuous representation. So you have x1 to xn, then you produce another representation to that one, Zn, then for given Zn, then the decoder generated output A1 to the AM of symbol of elements. So each step is like autoregressive that compute get information from the previous generated the symbol as an additional input. So somehow or the transformer is stacked self-attention and pairwise operations. Then you have the full connection. So you can from here you have the multi-head attentions. Then you have from that you have the feed for the neural network normalization. Then you feed it to the multi-head attentions. Then you have the feed forward neural network. Then you produce the output to feed it to you have the output probabilities. So it is based on an encoder and the decoder, of course. When you talk about the encoder, it's encoder, then you have the decoder. So the encoder is composed about the stack of n6 identical to the n equal to the 6 identical layers. So if you talk about you have 6, then you have another stacked identical layers for the decoder. So the key important for the transformer is about the annotation. So where the annotation you have the key and you have the query, key and the value, which has an output represented as vector. So then you have different dot product attentions. Then you have what you call the attention function, so which it depends about the query, and it depends on our key and the values. And this is the decay. Then you apply the softmax function to obtain the weight on a value. So this is multi-layered attentions. So they are described in details for this one. So you can read this in more details for this work. This is about the learning embedding and also the softmax. So those are very described in that manuscript. So large language model are advanced artificial intelligence. I'll talk about the large language model. So designed to understand and to generate demand like text. So this is an example. So you can have the robot which can try to respond to the question like a human, or it can try to summarize, translate, or to predict. So normally those large language model, mainly those large language models are practically based on a transformer architecture. So they are trained on a vast data set to learn the linguistic pattern and a contextual relationship, so that model can perform different tasks. So like text summarization, text generation, you can generate the text. You can give the topic, then you can generate the text details. You can have the summarization. So yeah, you give the text, then you ask the summary to give you the summary. It can be used for the translating from one language to another. It can be used for answering the question. Those chatting robots you can use for chatting. You can generate the code. If, for example, you are a programmer, you want to generate, like, for example, you have the program to generate the initial code. You can use for code generation like Python or Java. They can do it for you. And the amount task that language model they can use, they can give you. So characteristics for the large language model, they are based on transformer architecture. So most of those language models we are using, so they are pre-trained. So they are trained on a large data set. Then when you use it, it can be it can have the adoption to the specific task. So example, we have a GPT, Generative Pre-trained Transformer. We have a GPT-3, GPT-4, etc. We have ChatGPT, we have Codec, we have a DALI. So those are the different model. So we have the Google model like a BERT. We have a Meta, they have a LMA. We have, they are different. We have a Claude, which is a conventional large language model designed for the safety and accessibility. So we have also what you can call it, we have generative artificial intelligence. When you correct the generative artificial intelligence, they use the generative model. So to create the text, image, and the video. So generative artificial intelligence, so which can be categorized into two categories, can have the in a model where you fit one instruction or prompt, then try to generate the output, or you can have a multi-model. For example, you have a different, you are describing this picture, draw a picture, and write a song. So as you can see, we have different instructions. So where they fit into the generative model, then they produce a different output. So they try to describe this is the cat. They try to generate a picture of the cat. Then they try to write a song about the cat. So if you're interested in this one, you can check this survey. It is about comprehensive survey on AI-generated content. So this is the history for of generative artificial intelligence from different fields like computer vision, natural language processing, and vision language. So from 2014 to 2020. So there are many work already done for the generative artificial intelligence. So about the parameter, I already talked about before. The success of the machine learning depends on the data set you have. If you do not have data, it is very challenging. But if you have a huge amount of the data, so you can train the model and handle very complex task. So this is an example, different models and how many parameters you for the training that model. As you can see, you can have a video on the parameters for training the machine learning model. And thanks to the computational power. So now we have a computational capability so that we can handle those large number of the parameters. Of course, training those models, they require large amount of data. So we have what you call it AI generated content. So AI generated content, so refer to the content that it is generated by using advanced generative AI. So AI generated content. So it is it is referred to the content that it is generated by using the advanced generative AI. So which is opposed to be like generated by human author. So this is, for example, we give instruction to the machine learning. So then they try to generate the image for you, which is somehow very interesting topic. So AI generative content may not always produce the output that align with the user intent. So that's why now we have what you call the reinforcement learning from the human feedback. So you have the model, you have the content AI generated the content, you have the content generated by AI. Then from the content, you give the feedback. Maybe you say, oh, this content is not good. So it is like you are helping the machine learning to improve so that the machine learning can, oh, the content I produce is not good, I should improve. So this is so that they can try to improve. Every time the machine learning get the good feedback, it get the reward. When it get the bad feedback, it get the penalty. So now what you can is now how the reinforcement learning from human feedback come inside to fine tune the model. So in the various applications, such as, for example, ChatGPT. So there are many applications that use the AI. Thank you so much. Hope to see you again, and I hope you enjoy this course. If you have any comment or remark, this is your time, or you can send your comment by email. You are always welcome. Thank you so much.